So now let's talk about the triangle addition of vectors before we start learning about position vectors. Okay, the triangle addition of vectors. The triangle addition of vectors. The triangle addition of vectors is something that we talked about in the addition of vectors. Okay, let's say we have a vector like this. Okay, let's say we have a vector like this, and we are adding with another vector. Okay, I'll draw the arrow first. So let's say this is a vector, and let's say there is another vector. Let's name this vector AB. Okay, and let's say we have another vector that looks like this, and let's name it as BC. Okay, now you can find AC by using these two vectors. That's the idea behind triangle addition of vectors. Shall we look at how? Okay, how it can be done? Right. Okay, so I'll take this away. Right. So the triangle addition of vectors, what you do is you create a triangle by using the vectors that are given to you. So you have a vector like this and a vector like this. So if you add these two, you can actually connect these two to form the resultant of these two vectors. Okay, so I'll do that for you. Okay, so let's look at this. And now this is the triangle addition of vectors. The line that connects these two lines to form the triangle, okay, is called the resultant vector. Okay, so if you have A, B, and C, AC will be equals to AB plus BC. Okay. So in this case, a very important idea that you should keep in mind is this B disappears. Can you see that? Okay. A B disappears. So if you have some vector like AB, if they ask you that AB plus BC plus CD, you can say that is equals to AC plus CD. Why? Here you know AB plus BC will give you AC. Okay, so you can write like that. And then AC plus CD is equals to AD. Okay, and this can be understood as the polygon addition of vector. Okay, let's say if we have, in this case, we have three vectors here. So we have A. Okay, I'll draw straight lines. Yeah, I'll draw straight lines. AB, BC, and CD. Okay, and if you have something like this, if you have three vectors like this, AB, BC, and CD, the resultant vector will be equals to AD. The resultant vector will be equals to AD. Why is that? Well, I'll explain it to you. So first of all, let's look at this triangle. We can create a triangle here. We can create a triangle here. And that triangle leaves us with AC. But what happens is you should keep in mind AB and BC are gone. That part you should keep in mind. When you add AB plus BC, AB and BC are gone, and now you're with only AC. You have only AC with you. Okay. And now when you add AC and CD, okay, you will get AD. You will get AD. Okay. But what happens to AC and CD? Well, they disappear too. So the final answer will be AD. So this is the polygon law. Polygon addition of vectors. Okay, so these two are very important when we are talking about position vectors. Okay, now let's talk about position vectors. So position vectors is when you mention a position of a point with relative to another point. Okay, so position vectors. Okay, position vectors. You can say, okay, position vectors. You write the position of a point relative to another point. Relative to another point. Well, what do I mean by this? What do I mean by this? Well, you can think of this. Okay, you can think of this as normally it is the origin. Okay, this another point is normally the origin. Okay, they say position vector of A. position vector of a or let's say x, yeah, position vector of x with respect to O is some value. Okay, what do they mean by this specific expression? Let's say there is a point O, okay, and the vector that connects x can be here, x can be here, x can be here, x can be here, or x can be at the exact origin, and the vector can be null. But let's, for the argument, let's say the x is here. Well, the position vector of x means when you connect these 2 points, you can form a vector, and that vector is the position vector of x, and that vector is the position vector of x. This is very important because when we are talking about the displacement or velocity, acceleration, force, this is going to be very useful. That's why we learn position vectors. Okay, that's why we learn position vectors. Okay, here I want to tell you, if this is Ox, okay, you have to also know what is XO. Okay, what is XO? Well, XO will be equal to negative OX. Okay, negative OX. Look at this. How can you visualize this? Well, look at here. So this is OX. This is OX. If I change the direction, if I change the direction, we know it is moving in the negative direction. Okay, so we know this is negative OX. We know this is negative OX. But can you see you are moving from X to O in this vector? You are moving from X to O. So you can say XO is equals to negative OX. And this will also come in handy. This will also come in handy when you're doing questions. Okay, let's say OX, okay, the position vector of X with respect to O is equals to 1, 2, 3. Well, the meaning is OX is equals to 1, 2, 3. Then we know XO is equals to negative 1, 2, 3. Or you can say minus 1, minus 2, minus 3. Or you can rewrite this as minus I, minus 2j, minus 3k, XO. These are some different perspectives of looking at vectors. Okay, some calculations are easy to do with them, some questions are easy to do with them. So that's what we are learning here. So position vectors, I hope you understood what's the idea, what the idea is. Okay, so if we have one position vector, it's okay, fine, it's easy, it's simple, we just have to talk about the negative value and all. What if we have two position vectors? Okay, let's say points x and y. Okay, let's say points x and y, points x and y are position vectors x and y, vector x and vector y respectively. Okay, what does this mean? Well, if you want to visualize, that's great, you can visualize it. I won't say anything. Okay, so we have the point x. Okay, so point O, and x is somewhere and y is somewhere there. Okay, we don't know where they are. Okay, we don't know because we don't know the vector x is, what vector x is. So x is somewhere, y is somewhere. This is just visualizing, and these are the points x and y. Okay, these are the points x and y. These are the points x and y. So if you connect x and O and x, well, that is x. That's what they are saying. Similarly, if you connect O and y, the vector that is formed is equals to y. That's what they are saying. Okay, this is visualization. And you can say from this, we can find out xy. We can find out xy. Also, we can find out yx if we wanted. Okay, how is that possible? Well, we just connect these 2 points. Okay, this is the xy. Okay, this is xy. So to find out xy, we can say we have to go from x to O, then O to y. We can do that. That is also addition. That is also addition. That is just triangle addition of vectors. So x to O. Okay, we know OX is equals to x. That's what they are saying. Similarly, OY is equals to y. Since we are going from x to O, we have to say x to O is equals to minus OX, which means it is equals to minus x. Okay, so we are going from x to O plus O to y. So this will be minus x plus y, or you can rewrite it as y minus x. Okay, because a plus b is equals to b plus a. Vectors are associative, so you don't so associative and commutative, so you don't have to worry about that. Okay, so a plus b is equals to b plus a. Okay, that's it. Keep that in mind. Fine. Now, how can I do this without drawing a diagram? How can I do this without drawing a diagram? Well, think about this. Okay, think about this. Obviously, visualizing is good. Visualizing is good. But once you visualize, you should be able to understand the computation behind that. Okay. So here we have x and y, and they are saying the position vectors are vector x and vector y. So we can write down OX is equals to x and OY is equals to y. That's great. That's great. They want us to find out xy. I'll also do yx. So I can write xy as xo plus oy. Can't I? This O and this O will disappear. So I don't have to mind. And I know XO is equals to minus OX. And OY is OY, doesn't matter. Now I know we have vector X and we have vector Y. So that will be equals to minus vector X plus vector Y. So I can rewrite it as Y minus X. Okay, this is one way. And similarly, if I have to write down the YX, I know YX is equals to YO plus OX. And YO is equals to minus OY plus OX. So minus OY is equals to minus Y and OX is equals to X. So it will be equals to X minus Y. So this is how you have to think when you're playing with position vectors. You have to know how to perform these things, or else it will be hard for you to do this question. Okay, it will be hard for you to do this question. Keep this in mind, and I'll do practice questions in the next video.
Thanks for watching the third video in our vector series. If you found this breakdown of position vectors and vector addition techniques helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.